Okay, this is the fifth lesson, R.5 in college algebra. Continuing on with the review section, we'll call this R5a. Will obviously be the first video of a couple. The section looks kind of long, so it's going to take a couple videos to get through. The first section of this is called the domain of a rational expression. Now, the domain means what are the possible numbers for my x value that make the statement a true statement. So let's first of all look at domains that don't exist. Alright, so there's a rational expression. A rational expression means that you can write it as a fraction. So there's a rational expression. And what we're saying here is what numbers can we put in for x to make that a true statement or a possible statement. Doesn't matter. We can put absolutely any number we can in there for x, and we'll get something like, let's put 6 in there. And so x in there, or 6 in there for x, we get 6 minus 3 is 3. Okay? It's not that 2/3 is an answer or a true statement. I'm just saying, is it a possible answer? Well, it's a possible answer if we're looking at the set of real numbers. And my symbol for real number is an R with an extra leg there. Okay, that's how I write my real number symbol. So we're trying to find out what numbers can x be in order for my answer to be a real number. Alright, what would happen if I put a 3 in there for my x? I would get 2 over 0. This number does not exist. You can never have a 0 in the denominator. If you have a 0 in the denominator, it means that the number does not exist. It doesn't give you an answer of 0. Okay, there's a big difference between 0 and a number that does not exist. So the domain is any number that will keep the denominator from being 0. So the domain of this first one is the set of real numbers such that x is not 3. And we're going to write that like this. This is called set builder notation. So we're going to write it as x such that x is real and x is not equal to 3. So there is my answer in what's called set builder notation. My x can be absolutely any number I want it to be in the set of real numbers, except it cannot be 3, because 3 would make the denominator 0. So when you're looking for the domain, or what numbers make this an untrue statement, or a not possible statement, you're looking for the denominator, what's going to make the denominator 0. And when you get into calculus, you get into limit theory, and it kind of follows the exact same process there. Okay, here's part B. We don't even care what my numerator is. We're going to completely ignore the numerator. We're just going to look at the denominator. So what we're going to do is we're going to take our denominator of a trinomial and we're going to write it as 2 binomials. So 5 and 1, that's negative, so that's going to be negative, and that's going to be positive. So there is my simplified version of this trinomial. So what we've got then is x squared minus 4 all over, and I just simplified my trinomial on the bottom. Alright, what I'm interested in is, what is the domain? Well, the domain is x such that x is a real number, okay, and x is not equal to, what would make that 0? 5. And x is not equal to, what makes this 0? Negative 1. In parentheses. Okay? So what we're doing is we're trying to find out what numbers or numbers would make the bottom 0. And that becomes your exclusion. That becomes what it cannot be. So x can be any stinking number in the whole history of the universe except 5, except -1. So that's how we wrote that. And again, set builder notation, this little up and down symbol here means such that. X such that. Basically, x can be any number in the set of real numbers as long as it's not 5 and as long as it's not -1. So that's what the domain portion of this. And please don't think, oh, I've never heard of domain and how this all works. I'll learn it here and then forget it. Don't forget it, because if you continue on in math and you go into calculus, you're going to be using this all the time. In fact, we're going to continue to use it in this class throughout the semester. So don't just be like, okay, learned it, I'm done with it, I don't have to do anything else with it. All right, let's go on to simplifying, multiplying, and dividing rational expressions. Okay, example number 2. What we're going to do is we're just simplifying. Again, there's no equal sign, so we're not finding the value of x. We're just simplifying this so that if we were looking for the value of x, we're just making our life easier. Okay, so first step is we're just going to look at the numerators, and then we're going to look at the denominator, and we're not going to cross that division line until the top number or the top expression is simplified and the bottom expression is simplified. So don't start crossing this division line and start looking at this as oh, how do I divide this into this and da 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 da. Don't worry about that. Just do what's on the top, do what's on the bottom, and once you simplify the top and bottom, then we start comparing, if we even do that. Okay, so what we're going to do is we're going to look at this first expression and we're going to factor out a 3. Okay, don't forget the 1 there, it doesn't go away. And on the bottom we're going to factor out a 12. Okay, this cancels and turns into 1/4, right? So now we have 3x squared plus 2x minus 1 over 4 times x squared minus 1. That looks a little bit simpler, but not a whole ton. All right, so what are we going to do with that? We're going to see if we can factor that into two binomials. Don't know if we can, but 3 times -1 is -3. So we find a number multiplied together that gives us -3, added gives us a 2. Okay, so before I make these parentheses, let's rewrite that trinomial. So we're going to write it as 3x squared. Let's see, -3. The only option we have is -3 and 1, or 3 and -1. And we want a positive 2. So we know our biggest number is going to have that sign, that plus on it. So I'm going to have a plus 3x minus 1x minus 1. So again, I took that, and instead of writing it as 2x, I wrote it as 3x minus 1x, which is 2x. All right, and again, that doggone minus sign there. So let's rewrite this as 3x squared minus 1x. We put the plus sign in the middle there. And hopefully from the last lesson you remember that. We group. And what can we pull out of here? We can pull out of an x, and we're left with 3x minus 1. And what can we pull out of here? Nothing. And if there's nothing that we pulled out, what is there actually there? Well, there's actually a 1 there, right? So when we group these, we get x plus 1 and a 3x minus 1. So what I did is I used past math that we've done before to change this numerator into this. So let's go ahead and put it over here to the left as our new numerator. So instead of this, we're writing it as this, simplified. All right, now let's look at the denominator. Let's see if I can get rid of some of this stuff. So let's move all that up there. All right, so we changed our denominator, before I move all this up there, let's look at this. I changed my denominator to this. So let's go ahead and put that there. And what we need to do is look and see if that's as simplified as it can go. Can I simplify x squared minus 1? Yes, I can, because x squared minus 1 is the difference between two squares. I can take the square root of x squared, I can take the square root of 1, and I have a minus sign. So my numerator, I'm going to leave it the same. And my denominator, I'm going to write as the difference of two squares, x plus 1, x minus 1. And then I can cancel that with that, and I'm left with 3x minus 1 over 4 times the quantity x minus 1. And that, my friends, is as simple as you can go. There's no exponents, there's nothing you can reduce. Everything is good at that point. Okay, so here's example 3a. Now again, we're going to do everything we can to simplify the numerator, and then we're going to do everything we can to simplify the denominator. Okay? So first of all, we're going to factor out a 4x squared. That's what's common to everything. Okay? That really simplified it, didn't it? Okay, now we're going to simplify the denominator, or factor the denominator. Let's see, we can pull out a 2 and an x. And that leaves me with an x squared plus 3x minus 4 in the denominator. Alright, so the only thing that we can really factor here is this right there. Everything else is pretty much already simplified. So let's go ahead and simplify that. So we're going to leave our 4x squared times x plus 4 on top, and we're going to leave our 2x on the bottom, but let's see if we can simplify that into two binomials. So we have an x and an x, two numbers multiplied together give me a 4, added give me a 3. It's going to be a 4 and a 1. That's a plus sign, so my biggest number is going to get the positive. So 4 times negative 1 is negative 4. 4 minus 1 is 3, so that works. So on the bottom, we're going to put an x plus 4 and an x minus 1, and we're going to cancel that with that. This is going to be a 2 over 1. I'm going to cancel this x with one of these x's, and that leaves me with 2x on top, because that one disappeared, and that's going to leave me with an x minus 1 on the bottom. Okay, I'm going to work on R5b as in boy to do the second example in example 3, and then we'll go from there.